All right, so we're going to look at optimization again, but this time you're going to see a little difference in the domain and what you're going to have to do to justify an absolute. So it said find the points on the graph of y squared equals 2x closest to the point 2, 0. So let's see if we can get a picture just to understand what we're trying to do here. So that graph, if I were to draw y squared equals 2x, I'm going to have a piece there and a piece there. And if you're saying, I don't know about that, all I did was take the square root, but I've got to remember to put that plus or minus in there. So a square root curve, that would be the top half of the positive square root and then the negative square root. So the point 2, 0 is somewhere over here. So I'm asking, the question is, okay, what point is going to be the closest to that on that curve? And so I'm trying to figure that out. So let's figure out how we are going to go about that. Well, I'm trying to minimize the distance. So if this is the point 2, 0, and I'm looking for a point on the curve x, y, I'm trying to minimize this distance right here. So think about what the distance formula would be. Well, the distance formula is the square root of x minus the x coordinate squared plus y minus the y coordinate. So I'll just put in that 0. And just like yesterday, that's my distance formula in 2 variables. Let me see if I can get it in terms of 1 variable. So let me clean it up, and I think you might see it for yourself. If I did that, is there a way, do you see, to have the distance in terms of 1 variable? And hopefully you go, well, yeah, because look at this. Y squared is equal to 2x. And I'm going to just kind of simplify as I go. I have a feeling I'm going to have to multiply this out, so I might as well just do it. So I have, that's this part squared. And if I replace y squared with 2x, I have that. So finally I can get down to my minimum. I'm trying to minimize this, and it's the square root of x squared minus 2x plus 4 on what interval? Now I know you go, well, that's dumb. I know my minimum, my graph doesn't even go for x values less than 0, so I could put a 0 there. And that's really dumb to say could go on forever, because clearly a point way over here is going to be closer than a point way out here. But remember, when you're doing domain, you're talking about the mathematical domain, not what's reasonable and what logically can tell you. You have to consider all mathematical possibilities. So technically speaking, that could go on forever. Okay, the x value could go on to a billion. So that's why you have infinity. And that's where the difference lies in today's notes, is that you don't have a closed interval. One of them is closed, but it goes on forever. So how are we going to combat that? Well, that tells me I can't do the candidates test, because a candidates test is for a closed interval. So, all right, well, I'm jumping ahead of myself. Can't do candidates test, but what am I going to have to do? So here's the deal. I would have to take the derivative of this right here. And oh golly, that's going to be quite horrendous. Would you agree that if this is clearly a positive number because the distance is going to be a positive, would you agree that I could square that and I could square this side and I would get rid of the square root, and I could say, really, I want to minimize that distance squared, and I totally could. And that, if I minimize d squared, it's going to be at the same x value that would minimize d. That's just a whole lot easier to look at and find the derivative of. So I'm going to do that. So d squared prime is going to be 2x minus 2. Oh yeah, this is looking real easy. That the derivative squared is equal to 0. Sometimes people like to put that in parentheses, so it doesn't look like 21. The derivative squared is equal to 0. I could do that in my head at x equals 1. Now here's the deal. I'm going to do a sign analysis. Remember, AP doesn't grade that. But I think you can see if I put in a number less than 1, like 1/2, that would give me a negative and then a positive if I put a number greater than 1. So you can visualize what the distance squared graph is looking like. I would have a minimum at 1 and then it would keep on going up forever. But here's the part where it differs. I get it that you're going to have a minimum at 1 because, again, your graph is going to do that. It's going to decrease and increase. But the problem is you can't say that, oh, you have an absolute minimum at 1 because the derivative changes negative to positive. That only justifies a local max or min. So to justify an absolute, you have to bring in the domain. If you have an open interval or you cannot do the candidate's test, you are going to have to justify with words. You're going to have to make a statement. And I'm going to give you a form to do that for this type of problem. You're going to say, since the derivative squared is less than 0 from 0 to 1, and I could put an open circle on that because you're talking about the interval, and positive, I'll write it mathematically, I guess, from 1 to infinity, the only minimum on the derivative squared graph is when x equals 1. Okay, that is a key sentence. You're basically saying, you're describing, because remember, they don't look at sign analysis, you can't draw a picture. You're justifying that even though you have a minimum here, how do you know the graph, if I were drawing it pretty, how do you know the graph doesn't do this and dip down and have another minimum, a lower one, way down there? We're like, you're saying, well, it can't because you know it's always increasing. Okay, that's my point. You have to state that with words because, again, they don't read your sign analysis. And so basically that's what this statement is saying. Since your derivative is less than 0 from 0 to 1 and always positive from 1 to infinity, the only minimum you will have is when x equals 1. Thus, it is the absolute. You have just proven the absolute. Now, I have to answer my question because part A said find the points on the graph, did it not? Find the points on the graph closest to 0. So I'm going to do this. Closest points to 2, 0 are, now let me think about this. I should have figured out the numbers first. I know my x-coordinate is 1, but remember way back up here, I have y squared equals 2x. So if y squared equals 2x, then y squared is equal to 2 times 1. So y squared is equal to 2, and I would get y being plus or minus square root of 2. So the closest points are 1 plus or minus the square root of 2. And those are going to be my closest points on the square root curve. There's actually 2 of them, which makes sense because they're going to be equidistant from that point. So that kind of makes sense with my drawing. Now, the second question, really, if the question had just done part B, find the point, all that stuff with the graph, what is the shortest distance to that point, I would have done the same work, honestly, right here when I got 1. Let's go back. Now notice it asks for the shortest distance. So I'm going to plug back, way back up in here, I'm going to plug into my distance equation. And being that I only know x, I'm going to go to this line right here and just plug it in there. So let me do part B. So I'm coming back to this equation, x squared minus 2x plus 4. And we said that the distance is when the shortest one is when x equals 1. So I'm just going to plug in 1. So 1 squared minus 2 times 1 plus 4. And what does that equal? The shortest distance is 1 minus 2 plus 4, square root of 3. And that is your closest distance. So you still have to write your equation. You get it in terms of 2 variables. You still work on getting it in terms of 1 variable. You still write your domain. You still find where the derivative is 0. All that's the same. The key element of where this is different from yesterday is in the justifying of the absolute. You have to say it with words. You cannot use the candidates test, and you cannot just say the derivative changes negative to positive. That doesn't justify an absolute. So let's try one more. A Texas Ranger has 800 square mile rectangular plot of land he wishes to divide into 3 equal regions. As pictured below, find the dimensions of the entire enclosure so that the rancher uses the least amount of fencing. So it sounds a little familiar, and I have to go with the drawing and what's labeled. A lot of times they will label a picture so that everybody sets it up in the same way. And so that's what we did here. Now let's read it again. Okay, find the dimensions of the entire enclosure. So I'm obviously looking for x and y so that the rancher uses the least amount of fencing. Now notice that there's fencing. Every time I have a line, there is fencing. So y'all, you'd be surprised how many people cannot count. Okay, here's a y here, a y here, and a y here. And then you have another x over there. So what am I trying to maximize or minimize is what? You're trying to minimize the perimeter. Uses the least amount of fencing. So I am trying to minimize 2x plus 4y. Now I have to get that in 1 variable, yes, but that's ultimately what I'm going for. Now what's my parameter? What's my condition? He has 800 square mile rectangular plot. That means that x times y is equal to 800. Now again, I have to solve for one of those. Like I said, most times if you have x times y, people tend, and it's easy to solve for each. 9 times out of 10, people solve for y just because they're used to that. So I'll go ahead and do it. So what do we got? We have p equals 2x plus 4 times 800 over x. And that actually is my equation, but again, I go one step further because this is what I'll be looking for in your paper. When you're about to take the derivative, I'll just write that a little nicer. That's 3200 over x, so I'll just write 3200 x to the negative 1. Now what's my domain? Because you always have to have your domain. Obviously x is a distance, so you're like, oh, my 0. Does your condition have a minus in it? It doesn't. Notice that I have an open parentheses at 0 because you go, well, on the other ones you said that I could have 0. That's because of what my equation was. I cannot mathematically have 0 in that denominator because that would make the denominator 0, which is bad. So I will have an open parentheses at 0, and then technically, again, I could go to infinity because if two numbers have to multiply to be 800, one could be super, super, super small and the other one be super, super, super big. So there's not a limit on your, or a cap on your x's. So once again, the second I write that, I go, oh, I can't do the candidates test. So what do I have to do? I have to find p prime. P prime is 2 minus power to the front, decrease the power by 1. And I know what you're thinking. You're like, I'm supposed to do all this in my head? I promise you, you can. Okay, look, sometimes it's helpful to write it out. Let's set it equal to 0. And this is where I don't do the negative exponent. It makes more sense to do it like that to me. So what do I have? I have 2 equals 3,200 over x squared. Think about cross multiplying. So x squared, 2x squared would be 3,200. I think you see where this is leading. X squared is equal to 1,600. See, that's not so bad. So x is equal to 40. Now, I know that, again, when you solve for x, you get plus and minus 40, but remember my domain is only the positive, so that's why I'm only putting the 40 there. Now, I tend to double check that my derivative is going, if I'm minimizing, it should go negative to positive. Sometimes that helps me make sure that I have the right number. That should be a 40, not a 400. So let's put a number into p prime. I'm going to look at it in this form right here. That is p prime. If I put a number in like 1, well, gosh, 2 minus 3,200, that's going to be negative. And if I put a number in like a billion, 3,200 over a billion squared, well, that's going to be really close to 0, so it's going to be positive, so I'm looking pretty good. But what do I have to write? Get in the habit. If you do it on your homework, you will have the form down. My graph is doing this of p, so I'm going to say since p prime is negative on 0 to 40 and positive on or from 40 to infinity, the only, I tend to underline only always, minimum on p. This is important that you say that. So you're telling, hey, it's the minimum on p, and that's what you're trying to minimize, is when x equals 40. There's your justification. Now let's answer the question. What was the question? Did it ask for what was the maximum or the minimum perimeter? Nope. It says find the dimensions of the entire enclosure. So the entire enclosure would be x, comma, y. Well, we just said that the x was 40, and way back up here, looking right here, I know that y, if x equals 40 and y equals 800 over x, then therefore I can say y equals 800 over 40, so that equals 20. So to minimize perimeter, dimensions are x equals 40. What am I in, feet, I think, again? No, it was square miles, wasn't it? So miles by y equals 20 miles. A lot of times if x and y are labeled, I tend to make sure that I show which one is which. So x is 40 and y is 20. And there you go. So you're going to be doing a little more writing today. You're definitely going to be doing a little bit more writing, but it's very, very good practice. And when you write those things, you will tend to remember those things. So it's good practice for you, and you'll have it down.